So here's another example from 2012 in the AP exam, and again, similar to the last one, that we have a strictly increasing, though, twice differentiable function w, which means you can find both the derivative and the second derivative, and it's a change in temperature over time. And at time 0, the water temperature is 55. They heat it up for 30 minutes, and the data there represents how we are given that. So use the data to estimate w prime of 12. Estimate means find the slope. So just like the last one, we're going to find the slope here. Show the computations that lead to your answer using correct units. Interpret the meaning of your answer in the context of this problem. So the temperature goes from 67.9 to 61.8. 15 minus 9, you could calculate that. The correct units would be degrees per minute, and that means the water temperature changed at that rate over that time, because we're estimating the rate. Use the data in the table, so we're still approximating, to evaluate the derivative from of w prime. So if you think about your little song where you learned the integral from a to the b, said, hey, is the integral of b less the integral of a. So the integral of b is 71, integral of a is 55. Basically, it's a fancy way of saying that the temperature changed 16 degrees in that time. That was the total change in temperature at that time. For 0 to 20, the average temperature of the water, so they're telling you the average value of a function. Use a left Riemann sum to approximate it. So we're going to approximate by taking that 1/20th, and we're going to approximate this integral using a left Riemann sum. And then it says, does the approximation overestimate or underestimate the average temperature? And so, in other words, if you were making rectangles, would the rectangles be above or below the function? So all you need to know is the function increasing or decreasing. And they told you that in the beginning. If you forgot, you could plot it. If it's an increasing function, and you're doing left Riemann sums, it's going to be an underestimate of that value. And the left Riemann sums that you would use to find that would be the first interval, which is 4 times 55, plus the next interval, which would be 5 times 57.1. And this is a calculator question. The next interval would be 6 times 61.8, plus the last interval, which would be 6 times 67.9. And that you could add up and find out, and that would give you an underestimate of the value, because in your reasoning, it says explain your reasoning. Your reasoning is it's an increasing function, so it would be an underestimate if you use a left Riemann sum. If it would have been a right Riemann sum, it would have been an overestimate, because it's strictly increasing. For 20 to 25, use the function that models the water temperature, first derivative. Okay, so this is a different interval. It's off our table, and so you're going to use a calculator this time, but you have to always include your starting temperature. So we're at 71 degrees, plus we're going to take the integral from 20 to 25 of this function. So this is where you use your calculator, and either function integrate or the function on the screen. I would use function integrate. So function int of that thing, x 20 25, and that would tell you where you're at after that time. So all this is a model for how to see where the temperature changes. So it starts out general with a table and ends up specific with a derivative that you're going to take the integral of. And so, again, we talked through this problem in about 5 minutes. This is a problem where you could save some time. Very predictable what you're going to get with a table problem. And so it's good to become familiar with those.